Guys, we're going to start doing our presentation. So, hello, my name is Jessica Wells, and I am part of the product management team here at Cochrane Supply. I'd like to thank you for joining us for this Smart Building seminar focused on operational technology. We ask that participants make sure that they are muted during this presentation so that we have limited interruptions, and that you please save your questions until the end. Thank you in advance for your participation, and now I'd like to introduce you to our presenter today, Ping Yao from Optigo Networks.
Hi everyone, thank you very much for joining us. As Jessica said, my name is Ping. I am with Optical Networks. It's a pleasure to be part of this webinar. I understand that the intention of this webinar is to give everyone a chance to understand what is the networking component of a smart building, why it matters, and introduce you to one of the solutions that we provide at Optical Networks that we call Optical Connect. Is that correct, Jessica?
Correct.
Excellent. And let's move on. So at Optical Networks, we are a networking company. We offer network infrastructure solution and a network analytics. With the network analytics, I don't think we are going into today, but very, very briefly, if you are working with backnet systems and you have questions about how to evaluate the quality of the backnet system, check out a product that we have called Visual Backnet. And again, Cochrane Supply can help you with more details on that. But coming back to network infrastructure, networking has been around for a long, long time, decades. Since the 1980s, we've had IP networking. At Optigo, we focus on networking for what we call the operational technology world. So what we don't look at is we don't look at networking devices such as laptops and Wi-Fi for general purposes, printers, desk phones. Those are the world that we don't look at. We look at four major pillars: security, security cameras, access control, intrusion systems, HVAC, building automation, lighting systems, and energy, power, submetering, power, things like that. I think the most important thing to understand here is that, again, networking has been around for a long time. Networking is typically an IT responsibility. It's a responsibility of the IT team, sometimes subcontracted, sometimes it's one person, and sometimes you have a big team. But in our world that we're working in, we're working with operational technology world. These are people who understand building controls, air temperature, air pressure, access control systems, angle of cameras, fences, and all these things. And IT is not a core function until today of operational technology. We'll focus more today on building automation, HVAC. Everyone in HVAC understands IT is important, but because the growth of the Internet of Things, everything is now connected, and more is moving into a networked device, IP device. The concept of IT is very, very important. But if we always have to rely on IT external firms, IT expertise, then we can't do our job. IT folks are fantastic resources, but they don't understand what we have to work for. They don't understand the work that needs to go into to commission a data center, a high-rise, a shopping center, even a residential complex. Very often IT from our customers are not brought in until after the building is up and running. So what do? Can we, at Optigo, our motto is, can we provide an IT-like solution or IT solution for the non-IT folks, for operational technology? Traditional networking is very, very powerful, very complex, and requires a tremendous amount of skill and knowledge to run a complex IT system. You'll be using interfaces that look like the matrix right here in the middle, and understanding what a command line interface looks like. Lots and lots of wiring, lots of racks, and it's a lot of expertise. At Optigo, we want to bring something that allows this industry, again, building automation, lighting, security, energy, to be able to provide an IT backbone, an IT solution, without having to rely always on IT. Now, IT will always be a very, very good resource, and you should leverage their skills and knowledge. But maybe we can offer you something that you can control a little bit more yourself, control the work that you do, the time that you put in, and have IT as a partner, right, to help you out. A few things that are different. So even though we are seeing, connected thermostats, VAVs, controllers that are IP enabled, PoE lights, security cameras, these are all connected using a cable that looks exactly like an IT computer device, Wi-Fi station, a desk phone. Obviously, we'll talk about VoIP phones here. But there's some fundamental differences between OT and IT. Number one, in IT, it's mostly about moving data that is generated and consumed by people. Whereas in OT, we're moving data between machines, sensors, actuators, servers, to the cloud or within the building. The people that are responsible for these two aspects are very different. IT experts will have great certification, and they work in IT fields all the time, every day, in and out. Whereas in our operational technology side, it might be designed by an engineer, installed by an integrator, commissioned by an integrator, and then managed by a facility operator, a facility management team. The data is very, very different. In IT, the data is very, very sensitive. But in OT, the function of the building is equally as critical. If the door don't unlock when you want them to, or the temperature is not right, or worse yet, the lights don't come on. The other fundamental thing, and that we're going to go down in the weeds a little bit, in IT, we talk about burst traffic. Traffic that is less predictable, right? I'm standing in front of my computer right now. I'm broadcasting using video and over WebEx, but then I'll go for lunch. My computer is going to sit there. It's not going to do anything. Whereas in operational technology, when you set up a security camera and it streams 3.2 megabits per second, it's going to stream 3.2 megabits per second all the time. Now, it might fluctuate a little bit because of amount of detail in the camera, or at nighttime, maybe the IR beam comes on and it's a little bit different, but it's very predictable. A thermostat will communicate every time there's a change of temperature or every 15 minutes. Again, that predictable behavior allows us to treat the networking component, the infrastructure of operational technology, very different from IT. And that's what we do at Optical Networks. We are looking to leverage these different aspects between IT and OT and provide a solution for the OT world. Pardon me. Quick overlook at what we offer. In the end, they're switches. Okay, so if you already work with switches, from Cochrane or many other places, in the end, what we offer is a set of switches. But there's two main differences to what we offer. One is the management of this network, which I'll come back to, is significantly easier. And that's very, very important because, again, we're looking to offer a solution for the OT world. The folks that work with building automation, control systems, security cameras, and they might have to dive into the IT world once every 2 months, once every 3 months, for a week long while you're commissioning, installing, debugging. And after that, you go back and do programming of a JACE. You do programming of a VAV, right? You're looking at temperature. Yes? Go ahead. Are we good? Jessica? Yeah. You muted me?
No. Can you hear me?
Okay. Yes, I hear you. Should I proceed?
You're losing connection. Sure. Yeah, we lost you there for a few minutes.
Oh, that's odd. Okay. All right. Thank you. Right. So what we offer is a set of switches.
There you are.
What we offer is a set of switches, and there's two main differences between what we offer and the traditional switches you'll be able to buy at Best Buy or other places. One is the management of these switches, which we'll come back to in just a moment, is significantly easier, and that's very, very important because when it's made easier, it means that the OT folks are working once in a while, and they have to know IT, once every 2 months, 3 months when they're commissioning or troubleshooting, or installing the IT backbone, the whole system. That's when they need to dive into it. So if we make it easier enough, you don't have to do a crash course every time you want to bring up and enable a port. The second, we use a technology that's very, very unique called passive optical networking that allows you to create a network that's very, very large. Imagine a convention center, a high-rise of 30-story high, or a campus of multi-tenant residential apartments. The technology, the fiber optics technology we offer will allow you to save about 80% in infrastructure, which means less conduits, less material, less labor. And we'll dive into those each at a time. Am I still good, Jessica?
Yes, you're good.
Great. All right. Actually, you know what? I'm going to jump around a little bit. Let's look at some examples so you can kind of appreciate when you put the whole thing together, what you'll get out of it, and then we'll come back and dive into how you get it done. So here are 3 examples, very different examples. Top right-hand side, Asa Green Conservatory in Denver. Is a 16-building multi-tenant complex. They had to connect about 40 security cameras and access control systems, 60 of them. And their original intentions were going to run fiber between each building, and they would have had to install a minimum of 32 strands of fiber. And typically, you don't install 32 strands, so you install 48 or 12. And because this is a campus, they would have to run from a central location to each building individually. It would cost a tremendous amount of conduit space, fiber optics cables, and labor. I mean, every time you run a cable, you got to terminate it, test it, calibrate it, all these things. We came in and we helped them save 50% on the capital cost. So 50% on the equipment, because we reduced the amount of equipment they needed, and they reduced the cabling by 90% in this case. I don't like to quote 90% because it's, in this case, it was very, very optimal. But they save about 90%. So they were going to install something like 16 cables at 12 strands each. And here they installed 2. And they ran around the campus and they connected everything together. On the bottom right-hand side, Short Pump Town Center in Richmond, Virginia is a shopping center. The cool thing here is that the technology that we offer, which we'll come back to, called passive optical networking, allowed them to scale this the installation of the 80 IP cameras over time. In fact, we just got an order after 2 years that they're going to keep scaling it. What I mean by that is, instead of having to install the whole thing all at once, which you can't do in an existing shopping center, it allowed them to install one piece of it, run a little bit of fiber, and kind of bring up a portion of the town center, then close off another portion, extend it from the existing fiber, extend it, and keep going. And obviously, their tenants will move things around. They move a tree, a door, whatever it is, and they had to be able to react to it. So that fiber optic technology we offer with splitters allowed them to adapt as the environment changed. On the left-hand side is a 33-story high, I think, plus parking lot, a fully converged system. So IP cameras, access control, HVAC, lighting, elevators, all on one common backbone. And the backbone now was owned and operated by a HVAC by trade system integrator. Now, they are very, very advanced today, but the technology we allowed them to win a very, very large bid and be able to own the IT infrastructure of this whole building without having to outsource it to an IT firm. By the way, in Torrediana here, the entire building was connected, I think, with 6 strands of fiber. If you did it traditionally, you would have needed about 90 plus. All right, let's keep going. Let's dive into it a little bit more and find out how that is possible. The product that we sell, the product line that we sell is called Optical Connect. And again, Cochrane Supply is one of our major distributors. So if you have any questions on pricing, you want to quote, you want help with design, reach out to them and they'll help you. We break down the system into 3 main components. we have on the right-hand side, we'll start with the right-hand side, these are switches, right? You choose a 4-port switch, a 16-port switch, 24-port switch, PoE, no PoE, they're switches, right? So you connect, it's Ethernet in, Ethernet out, you need PoE, use PoE, the rack mounted or the DIN rail mounted. So the one on the top right-hand side here is C1601 PI, is a DIN rail mounted, no fan, and so it fits very, very nicely in the cabinet. We have a 4-port version of it. We have 24-port. Again, this is not the full family. If you want the full list, reach out to the comments of mine. So again, on the right-hand side, they're just switches. We're going to go to the left-hand side now. On the left-hand side, we call these aggregation switches. Aggregation switch is, sometimes people call it a core switch. It's not quite the right term in this case, but it literally pulls all the data back into one central location and redistributes it as needed. It goes to the server, it goes to another switch as necessary. But what the magic is here is the head-end switch is also where the network management comes in, which I'll go into just a moment. In the middle, these are little plastic boxes, but this is where the magic lies. These are splitters. Let me see if I have, yeah, these are little plastic boxes, and they allow you to take a single strand of single mode fiber and physically split it to create more fiber optics. So those who have worked with coax, these are like T-taps, right? Splitters in coax. You had one coax, you run as far as you want, you put a T-tap and you go in 2 directions. You put a splitter, you go multiple directions. If you work with MSTP, although not recommended, you could do a split in an MSTP. Not very good for MSTP, but it does allow you to do it. These are the splitters, and splitters come in many, many forms. They can go 1 to 2, like the one that's shown right here in the middle. It can go 1 to 4, all the way to 1 to 32. They can be stacked, they can be daisy chained, and this is when if you let your imagination go, you can go into a large project and drastically reduce the infrastructure necessary to interconnect all the switches, the floors, the buildings, the different comm rooms. These splitters are completely passive, so it means there's no moving parts, no electricity needed. They are literally a little piece of plastic and glass. Give me one quick second. Hey, Jan, can you buy me a splitter? I'll show you physically, since we have video here, what it looks like. Now, the distance between the active equipment, so the aggregation switch to the switches on the right-hand side, they can be miles apart. In fact, we support up to 14 miles if you wanted to. We recommend, 5 miles. If you need more than 5 miles, let us know. We're just curious to know how you're using our product in a more than 5 miles in installation. It's never been a problem. Most of our installation are in buildings or in small campuses. Thank you, Jen. So it hasn't been a problem. One of my colleagues here brought me a splitter. This is a splitter. So it looks like a little box of cards. It's completely plastic and glass inside. In this one, you have 1 fiber coming in, right here, and 2 fiber coming out. And again, we have lots and lots of variants, 1 in, 2 out, 1 in, 8 out, 2 in, 2 out, if you want it redundancy, which we'll touch base in just a second. I hope there's lots of questions. There should be lots of questions when we get here. But we'll hold them to the end. I'll try to speed up a little bit to give everyone a little bit more time for asking questions. Without going into a ton of detail, I was saying how if you let your imagination go, you can create very, very complex fiber optic networks that allows you to drastically reduce your labor, your conduit, and your material that you need for the infrastructure. So here's an example, 1 in, 8 out, then go to 1 in, 4 out. You can do a daisy chain, very, very popular for us. If you flip on its side, vertical, this is a high-rise. You can go from the main comm room to 1 floor, connect the switch, go to the next floor, connect the switch, go to the next floor, and the whole thing connected to 1 strand of fiber. If you want redundancy, because the head-end switch is your single point of failure, it's very simple. You can replace this 1 in, 8 out with a 2 in, 8 out, and there you go. You've protected that single point of failure with a second one. Daisy chain, same thing. If you wanted to protect the head end, you can put in the second head end, and now you've already protected it. In this self-healing passive ring, it actually also protects fiber from being cut. If you cut the fiber, Part of it will connect to one box, the other part will go to the second box. Okay, let's talk about how you compare to how you do things today. If you were to install an IT system for a high-rise, let's say you have a 12-story high building, you would typically do what we call home run design. You would install your switches, and from each switch, you would drop a dedicated cable down to the main comm room, where you have a big honking switch to aggregate all the traffic and redirect it. And as I said earlier, with Optical Networks, you can do the whole thing with a strand of fiber where you split on every floor. Now, there is a limit. The bandwidth limit is 1 gig with Optical Networks. Every what we call optical network, so optical network is 1 gig. So the aggregation of these switches gives you 1 gig. And there's a limit in how much you can split the fiber. It's 28 dB for those who are familiar with that stuff. And again, if you want more details, reach out to Cochrane Supply. They'll help you with the design, and we can help you also there. There's some design guides to help you. But basically, if you're doing a high-rise, you can do, in the daisy chain, you can do 10 to 12 floors, splits, I should say. So if you want to do multiple floors, you can do even more than that. If you're doing more of a star shape, like this one, the rule of thumb is basically 1 to 32. So if you're doing a campus, for example, you could go from 1 location to 32 locations with 1 split. In this case, what you save is a lot of cabling, a lot of SFPs. If you were to do the left-hand side with fiber optics, you would have a laser on every floor going to every switch, and a laser at the aggregation switch on both ends. In this case, you have a laser on every switch, and you have 1 laser for the whole thing combined together. So again, we can go into much more detail. Price list is available at Cochrane Supply if you want some questions. Have some questions. Let's go into management now. We talked about the physical aspect of Optical Connect, how you use Optical Connect to save the amount of money, capital cost, the infrastructure necessary, and hopefully reduce the space that you need to install and create a large network. Let's now look at a side that sometimes is overlooked, what we call network management. If you go to Best Buy and bought a cheap switch, you will likely get an unmanaged switch. Unmanaged switch will work, but when it doesn't, you have no clue where it goes. In today's world where cybersecurity is a very, very big deal, and also convergence being one of the biggest trends, actually it's no longer a trend, it's a reality, where you have a network that connects HVAC, lighting, maybe multiple HVAC vendors, energy, parking systems, whatever you want. You need to separate each services, each vendors, and sometimes each building or each floor. So you need to go into a managed switch environment. With the managed switch allows you to do simple things like, hey, I don't want my lighting system to touch my HVAC system. I don't want building A to touch building B. You bring everything together. It would be exactly the same as running separate networks, so separate boxes, separate cables, but you do this logically, so you need less cable and less boxes. So that's one. Second is, if you have an open port, that's a threat. Another vendor comes in, unintentionally plugs in, floods the network, and takes everything down. You should disable ports you don't use. Third is, once you've connected, say, a VAV to a port, why should you not lock that port to only that VAV? You shouldn't have to move it. And then another simple cybersecurity best practice. So if you went and bought traditional switches, managed switches, you would have to manage each switch using a command line interface, or maybe with a GUI, but individually. Each switch, you would have to go in and say, I want port 12 to be disabled. Then I want to go to the next switch. I got to remember the username, password, and the IP address of that switch, and go in and go in and go in. Again, if you're doing a small project with 1 or 2 switches, maybe that's not a big deal. You go into high-rises, 30 floors, you go into a convention center, you go into a shopping center with 15 switches, 20 switches, and the person that's working on is one of your staff, hopefully knows a little bit about IT, but not to the point where they're very, very comfortable working in the matrix world. Give them a tool that's much easier. This is where we come in. We provide what we call a unified or centralized network management interface. beautiful, point and click, use the mouse, you point on it, you don't have to remember really how to do this, very intuitive, and everything is centralized, so no matter how many switches you have going to one aggregation switch, it's one place you go to. One set of credentials, one IP address, you log in, you see an entire network, no matter how big it is, and from there you can enable, disable switches, ports, pardon me, you can do your software update, you can separate by VLAN, separate the services, again, you know, I want my cameras on this one, I want my HVAC on that one, all from one place. The interface is done to be very, very intuitive. You can point and click to enable, disable PoE, enable, disable the port, put some descriptions for future use, or you can PDF it out for your as-built documentation. You can set your VLAN very, very easily. You can click if you want to look for more information. Hey, you know, 2 years out, my customer is asking me to add a lot more information, a lot more data, a lot more devices. Do I have the capability for it? Do I have PoE budget? How much bandwidth am I using? Very, very simple things to do. Last but not least is what we call one-click secure. It's a very, very simple one-click to secure your whole network. It is meant for you do your whole design, you commission the building, and when you're ready, you say, okay, everything is up and running. I click this one button. It disables any port that you don't use. It locks port that is connected, and voila, you're done. I mean, again, simple things to bring the level of security of your system up a notch. I think this is all I have. In summary, Optical Connect is a networking interface, infrastructure, IP, for connecting HVAC, security cameras, lighting systems, energy systems, anything that's IP. You can do that for your installation, your projects at a fraction of the cost in terms of infrastructure, and make it easy so that you can keep the expertise in your court, in your staff. They don't have to be network experts to be able to set up a scalable and secure network. That's all I have for now. If you have any questions, I think right now we'll open it up. No questions? I can see the names. I can call up some names.
Yeah, I'm just wondering if everybody's still muted to where they can.
I see. Yeah.
I'm not sure. All right, well, if there's not any questions, we appreciate your participation in this WebEx. If you have any additional questions, please reach out to the Cochrane team or ping. We hope you'll join us on one of our many upcoming Smart Building seminars. Please make sure you're subscribed to our mailing list by visiting cochranesupply.com. Thank you, guys.
Thank you, everyone. Good luck.
Thank you.
Bye.